Today I'm going to be talking to you about Smart Mentor Dispatch. So this is partnership between a bunch of different organizations. So I'm from McMaster University. We run this program called McMaster Start Coding, which teaches kids programming in the area of Hamilton, which is about an hour from Toronto. And we've just also started a nonprofit called Stable Foundation. So a little bit about McMaster Start Coding. We visit grades 4 through 8 and beyond, also high school, and sometimes even younger. We teach Elm. If you're not familiar with Elm, think of it like baby Haskell without typed classes, and it's used to make web apps. We are run by mostly undergrad and graduate and high school student mentors, so they're volunteers, but we also have partnerships with school boards where we can pay mentors to actually go and teach our content as part of the math and coding curriculum in schools. And over the last 5 years, we've visited over 26,000 students. So along with this, we need an easy way to actually visit the classrooms and have them be able to code. So we've developed an online system. This is actually an older version of it, but essentially the students can go here, compile their code. That's what's nice about Elm, is that we can run it right in the browser. There's no installation. It's really hard to get things installed on school computers. We need approval, and we need a lot of foreplanning. It's much easier if we can just visit a website. They can log in, they can compile their code, and then they can actually share it with each other, and we even have new features like being able to import each other's code and work on things collaboratively. So here are a few examples. We've developed a graphics library. Kids can create animations. Basically in about 20 minutes we can get them started, and they can start creating things like this. We asked them to create emojis, so these are some of the things they came up with. There's a pig, and this right here, I don't know if you can see it, but underneath this annoying UI, which I don't know if I can get rid of, it says Axe Cat. So this is a character one of them created called Axe Cat. So we used to go almost exclusively into classrooms, and we just used our online system as a way to compile code. But obviously, with the pandemic, we were whisked into an online virtual world very quickly. We were actually in the middle of a weekend camp where kids were making a game about COVID and COVID safety. And we started the game, basically, it was the weekend of, I think, March 6th. 2020, and it was a 2-weekend camp, and in the middle of that is when everything shut down, and we actually were online for the second section of that camp. So we were kind of whisked online very quickly, and what this meant was we needed way more better mentor features to be able to support virtual learning and going to classrooms virtually. So we have some questions about this. So how can we, the first one is, how can we identify students which need help? So far we have a chat system where they can ask questions. They don't always ask questions. They sometimes sit there and they're a little bit confused and they just kind of get stuck. Or the worst thing is that they just kind of stop doing it altogether. It's a lot harder to find out who's having problems and help them when you're not able to just walk around and look at their screens. The other thing is, how can we empower the mentors and make best use of their resources and help students when they need it most? We don't necessarily always want to just help students right away when they get an error, because sometimes the errors are simple enough that they can actually fix them themselves, and that's a good learning as well. So we don't necessarily always want to help them right away, but what's the best time to help them, and how can we help the students who need it most? So how can we address some of these concerns that I was mentioning? So some ways are to give mentors access to real-time insights from students' code, basically keep a data set of compilations and errors, predict time to resolve an error, and then also cluster groups of students to determine which ones are struggling with similar problems and which ones are in need of help the most. So this was an initial project where we took this data. Over the last 5 years, those 26,000 students have pressed that compile button nearly 5 million times. So we have a lot of data to work with, and so this project is looking at some of that data. So this is the older style homepage where we had different slots. So this one here is an animation slot, and so I just wanted to give you a little bit of background. So we have different activities, for example, animation slots or game slots or different things like that, and that's just that helps us organize and figure out some things about different statistics for different types of activities, which we'll get into later. So the first thing we looked at was very simple statistics, just like the number of compiles per slot, and so this is a pretty graph showing that. So this is just showing which ones are used the most. You can see that the game slot is a really kind of popular one, animation slot, picture slot, etc. So that was some basic animation. Statistics. The next thing we looked at was what are the most common errors for different types of slots. So that's actually interesting to see. So for example, when we're making our Elm programs and making animations, the animations are just lists of shapes of some type called shape. And so for the picture slot, the main error that they're running into is just syntax errors in terms of putting commas between their shapes, basically. And so we have a lot of unfinished list errors for the picture slot. But then when we get into things like games, we started seeing more advanced errors. So by the time they're making games, they're beyond the basic syntax errors, and they're making things like type errors and that kind of thing. So this was one of the first big insights we gained, is that the errors that they get are different depending on the activity that they're doing. And then we also wanted to look at trying to predict time to resolve errors. So being able to kind of match that, fit that to a power law, for example, and basically just predict time. How long does it take a student to resolve an error? And that way we can let them have maybe enough time that they have time to think about the error and resolve it themselves, but then not leave them hanging too long. We definitely don't want them to be out here in this sort of tail. We want to basically detect when they have an error. So this was just looking at the data, and a lot of these ones way out here might have been some of these could be that they just left it for a while and came back to it later, for example, and that kind of thing. Most of them sit in this sort of 5 to 10 minute range, I'd say. And then the next thing we wanted to do was look at some basic clusters and try to figure out if we can determine some similarities amongst different problems people are having, for example. And so we just did some very basic k-means clustering in Tsne. This was performed by a graduate student in our group. And so we'll take a look at a couple of these clusters. So we had this cluster 10 and cluster 33. So let's just take a look at cluster 10 first. So in this case, these people seem to all have basically these students were having pretty good luck with their slots. So they were always compiling successfully for the most part, and by the end they were all successfully compiled. So we looked at different statistics like the errors, the number of final compiles they had, but also the number of compiles in between. And so this would be an example where basically the student's doing well and then they end up doing well. The next one, cluster 33, is where we might actually start dispatching mentors to help. If we detect that they're in this kind of cluster, then this is where we might actually want to help them more. So the interesting thing is, for the most of the time, they successfully compiled their code, but then 57% of the students, only 57% of the students actually had a successful compile at the end. So essentially, these modules were just left with some sort of error. And so if we were to detect that they were in this cluster, we would definitely want to go help them and sort of dispatch a mentor and say, hey, do you need some help? Even maybe before they ask a question on the online chat. And this is just a deep dive of one of the examples. So this one would have been where they tried to so this is just basically a typo, honestly. So they put spot here, but their actual they actually used. So maybe I think this was maybe they were making some sort of leopard or something like that, and they have a spot, and then they have, but they just misspelled it. So that's one example. Okay, so again, this was just an initial deep dive into the data offline. Eventually, we want to actually add these features to our online system, and so as people are using it, it would be generating these analytics and sending mentors. So the basic idea would be that the students use the system, and then the mentors are given insights and also can analyze insights by themselves. And then the mentors help those students, and then hopefully this cycle kind of continues, and we can reduce those times, the errors the times that they're in error, and also decrease the amount of people who basically just abandon their modules or just stop working. This is especially a problem from home when the teacher's not there to keep them on track. So we want to be able to kind of proactively find out when students are struggling and help them. And so here's some desired outcomes that we hope to get from this. So for one, that the mentors would be able to analyze these and figure out what clusters students are in. Honestly, one of the things is just determining which of the clusters are even interesting to us. That first one we looked at, where they were working well and having 99% good compiles, that's not quite as interesting to us as maybe some of the ones where people are struggling. We want to quickly identify whether new students or even existing students are struggling or not. And then develop preventative measures to prevent this. So for example, if we're seeing one type of error a lot, we might be able to eventually build in tips that would help people with that error, or even detect certain errors and give automated tips rather than always having to have a live mentor as we currently do. And then also we want to identify some of the root causes of the problems that people are having in specific clusters. So maybe we determine that these certain types of students or certain types of modules are always having one type of error, and that kind of thing, find the root cause. Okay, thank you. I'll take some questions. I think I have some time. If you want to visit us, here's our website for the McMaster Start Coding and also our nonprofit, and then our emails are here. That's my email here, and the program email if you're interested in contacting us. Thank you.
Holy cow, you caught me by surprise. I didn't even have a chance to show you 5 minutes time mark.
Oh, okay.
Okay, thank you very much for that.
I
see you have lots of questions. So, but I almost forgot. This is Victor. He's going to circulate the room and gather your feedback, which means press the, you know which button.
Yeah. So you're mostly focused on students who seem to be struggling a lot. But another thing we know, especially in primary schools, is that students sort of don't get challenged enough. So another sort of interesting thing is, you say that the perfect cluster in some sense is not interesting, but actually I feel like it could be interesting. So is this something you've also worked on trying to detect?
That's a really good point. Actually, yes, I probably misspoke when I said that. This is something we've done manually for sure. It's something I didn't think of before. What we've done manually for as when we've gone into schools and even when we've been virtual, if a student is doing really well and they finish their animation really fast, or we give them the task of making an emoji, there are a subset of students who do finish these really quickly, and then we do give them, we say, hey, if you, maybe we suggest, we might teach them how to do animation before we teach the rest of the class, or that kind of thing. So that's actually a really good point. We mostly focus in this presentation on maybe more struggling students, but also, yeah, maybe suggesting, you look like you finished really fast, here's like a YouTube video showing a more advanced concept you might want to try, or that kind of thing. So that's a really good point. Thank you.
Thank you for the talk. It was really nice. I was wondering, because this is the first time I heard that Elm is used for teaching programming, like for children. And I was wondering, how does it work well? Like usually people choose programming languages like Scratch, which are designed in this goal to be like for children. And does anyone else use Elm for teaching programming? Or is it your idea, and how do you think it works?
Well, we found it actually to work quite well. We don't obviously teach anything too advanced right at the beginning. We stick with our kind of DSL, our graphics library, and we teach them sort of a subset. But we do have lots of students that then take that really far and actually go, all the way from our basic one-day lessons. In the next talk, I'll talk a little bit about some of our camps that we do and more advanced things that we do, making games and that kind of thing. What we like about Elm is that we can teach a small subset, and then they can actually build that up into a full thing. Unlike Scratch, that's a little bit more, it's just meant for teaching. Ours can actually build up into like a full-blown web app, and we've had students actually, build it up and work on much bigger things. The other thing we really like about it is that rather than it being this imperative idea, a lot more natural. We find that functional programming, and Elm in particular, is a lot more natural with what they've understood from their math classes. One time, for example, I saw a student, we taught them about if-else expressions, and we were just using it to flip between two different colors, for example. But they realized that they can actually put that if expression anywhere and another expression can go, and they used it to switch like between two different shapes, for example. So we found that it's actually pretty natural to them. It supports their sort of understanding of math naturally in this sort of algebraic thinking kind of concept. And so that's why we found that it works well for us. And then we can build up into the more complicated maps and folds and all that type theory, whatever, if we want to. But we mostly stick with the beginner stuff for the beginners. Does that answer your question?
Hi.
Hi.
Are your resources available for other kind of settings, like such as self-learning, or maybe like some non-structured, just one day workshop or stuff like that? Is there a curricula that other people could adopt, maybe?
Yes, one thing we did with COVID is because we had so much time at home, we spent a lot of time developing curriculum and videos and that kind of thing. So we have a YouTube channel that takes you through. We have structured numbered lessons, and I believe we have those in text form as well. I'm not sure if they're available, but you can always contact us if you'd like those. And yeah, so I would say if you want to, you can. Our website should have the YouTube. I think the YouTube is just youtube.com/McMaster Start Coding. If you want to follow through those, and if you email us, we can give you access to. We can give you a login if you want, and that kind of thing if you want to actually use our system. But the graphics library is just freely available as well, so you can install it using Elm package and just install that on your own computer and code manually. It's just that our thing already has the libraries built in, and all the boilerplate stuff is hidden from them. They only have what's available to them is only the stuff they need, like the list of shapes and stuff. So it's all freely available, yeah. The system itself is not open source, but the library, the graphics library, and the Elm stuff is yeah. Yeah.
So now it's me. What's the age of your students?
So the ages, it's grade 4 through 8, which is approximately 9 through 13. We do go into high schools as well, which would be up to 18. And we have visited with some of our simpler tools and lessons. They don't actually get into the coding, but we have some tools that they can use. We've gone actually as low as even kindergarten a few times, and just teaching very basic things. We have this shape creator where they can create the shapes without actually typing the code in, just by tapping through menus and stuff. And we think of it as just a documentation tool, but they seem to love it. It's actually amazing. Something we consider kind of pretty simple, they actually really take to it. So. Is there one more question?
Yeah, just one more.
I'm not sure how we're doing. I don't want to keep you from your lunch.
How far you go with teaching? What is the hardest topic that kids can teach in your system?
So when we go to schools, we usually start with graphics, and then we might get into animations, which is where we teach essentially introducing a time variable into their program, so they can make things shrink and grow and rotate and different things like that. We even teach them, they don't really understand it, but if they want to make things move back and forth, we can teach them sine and cosine and that kind of thing, or just show them how to do it and show them how to adjust it. And then in our camps, we go as far as teaching games where they're actually coding some logic using Elm, and using kind of sort of this model view update paradigm that Elm gives you. And I'll touch on that stuff in the next talk about state diagrams. We've actually developed a tool to kind of make that a little easier, so that talk's right after lunch as well. So I'm going to talk about that in more detail. And then we've had other students where they actually, some high school students for volunteer hours or just for their resume, they want to work with us during the summers and help develop stuff. So we've had some students actually work in a sort of we call it internship style summer camp, where they can actually work on more advanced things. And so it's really, we have this subset of students, as was mentioned, that go really far with it.
Okay, sorry, we have no more time for any questions, so another round of applause, please.
Thank you.